Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Sufi bin Ruslan, and today my group and I will be presenting about NUMA. So this is our group members, which consists of myself, Muhammad Sufi bin Ruslan, Muhammad Syami bin Kamarud, Muhammad Saifuddin bin Idris Shazali, Muhammad Zulfadli Adli bin Ahmad Faizul, and Nurain Syuhada binti Abu Bakar. So first of all, what is NUMA? NUMA actually means non-uniform memory access. It will actually take longer to access some regions of the memory than the others. NUMA is actually designed to improve scalability on large symmetry multiprocessing, which can also be known as SMP. The processor, CPU, can access its own local memory faster than non-local memory. Next, so what is NUMA node? NUMA node actually means a group of processors which have their own local memory. Any processor can access any memory, including the one that is not owned by its group. The non-uniform one can access local memory faster than accessing remote memory. Next, I'm going to talk about some history of processor or NUMA. So first of all, the mental model of CPUs is started in the 1980s, which is basically boxes that do arithmetic, logic, bit twiddling, and shifting, and loading and storing things in memory. But various newer developments like vector instructions, which can also be known as SIMD, and the idea that newer CPUs have support for virtualization. Second of all, many supercomputers designs of the 1980s and 1990s focus on providing high-speed memory access as opposed to faster processors, allowing the computers to work on large datasets or at speeds other systems could not approach. Last but not least, the first commercial implementation of a NUMA-based Unix system was the symmetrical multiprocessing XPS-100 family of servers, which is designed by Dan Gillen of VAS Corporation for Honeywell Information System from Italy.
Concept NUMA. As we can see here in diagram 1 and diagram 2, each CPU is connected to its RAM by a bus. Each of these pair, we can call it as NUMA nodes. But if we combine the diagram 1 and diagram 2 all together, like this, it is called NUMA system. How NUMA works? So, NUMA is a computing system composed of several single nodes in such a way memory is shared between all nodes, which means each CPU is assigned to its own local memory and can access memory from other CPUs in the system. The closer the memory to processor in the term of access time, the faster the total input-output of the system will go to enhance all the aspects of system performance. For example, the use of the cache to store frequently accessed hard drive data. Access speed of even a slow memory is much faster than even the quickest hard drive. The end of the result is a much faster machine. For processor and memory, the same trick works by using small quantities of fast RAM either on the chip itself or directly next to the CPU. Why we use this trick? To speed up the main memory output in the same way as the hard drive cache speed up the performance of the disk.
Okay, now I'll be talking about NUMA's features. Okay, NUMA's features. The architecture of NUMA was largely established due to the introduction of modern microprocessors that are faster than memory speeds. As a consequence, local memory is put closer to the processor, shortening the length of signal path and reducing latency times with less memory access delays. Okay, there are few of NUMA features which is to compensate for memory latency effects, due to some memory being closer to the processor than others. And the features are, first, useful to scale the virtual machine for large amounts of memory. Second, memory is placed local to the processors accessing the data to improve performance. Third, if the computations or data requirements are beyond the capacity of a single NUMA node, then data and processing need to be spread out. Fourth, NUMA also balances access to data on various nodes through the processors available. In newer Linux kernels, NUMA Auto Balancer is automated, otherwise manual control of affinities and memory policies is necessary for proper performance.
The advantages of non-uniform memory access is each processor has its own local memory module that it can access directly with a distinctive performance advantage. At the same time, NUMA can also access any memory module belonging to another processor using a shared bus. The third advantages of NUMA, it can improve average case access time through the introduction of FAST, which is local memory. This is because NUMA is a hierarchical architecture. And the last advantage is process accesses its local memory faster than a non-local memory, which is a memory shared amongst processors. It means that NUMA use less time to access or reach the local memory if we compare to the non-local memory. Next is the drawbacks of non-uniform memory access. First, NUMA will not automatically do the right thing all the time. There are two reasons. The first reason is the operating system cannot expect the memory access patterns of the application. And the second reason, the system might be oversubscribed and the processor must be shared. The second drawback is the more elaborate of the design system, the more expensive it is to produce due to increasing amount of processors in the system that will be used in the future. Third, NUMA system lacks scalability in terms of the memory and CPU. When we add the more CPU in the design, it can increase the traffic on the shared memory CPU path. The system heavily relies on the responsibility of the programmer for synchronization that ensure the correct access to global memory.
So today I will talk about implementation of NUMA. NUMA stands for Non-Uniform Memory Access, which is a computer memory design used for multiprocessing where memory access time depends on memory location. So we will go the first one. The first one is Windows 7. Windows 7 is an operating system developed by Microsoft and it already supports NUMA. Because of NUMA, it will increase the performance and improve multiprocessing as they share memory locally. So the next one is Java Hotspot Virtual Machine. Java Hotspot Virtual Machine also added support NUMA and garbage collector. This will improve the amount of time to access the memory, while NUMA Aware Allocator provide automatic memory placement optimization for Java application. This will give impact to the performance of the system to go smoothly. The last is Linux 2.5. Linux is also an operating system, but 2.5 is a bit older. Nowadays, Linux latest version will probably be 5.0 and above. But the interesting part is Linux 2.5 is already added NUMA support. It will minimize the memory process and manage instances such as share pages between processor or clear enormous space. The higher the Linux version, they enhance the NUMA and the system, but it will cost you more.
Okay, as for the summary, NUMA is non-uniform memory access is a method of configuring a cluster of microprocessors in a multiprocessing system. NUMA is used in SMP, which is symmetric multiprocessing, is a tightly coupled, share everything, device where multiple processors access the memory of each other over a common bus. SMP and NUMA systems are usually used for applications such as data mining and decision support system, in which computation can be partitioned to a variety of processes that operate together on a shared database. NUMA is a computing system composed of several single nodes in such a way that the aggregate memory is shared between all nodes. NUMA takes cache basic concepts of memory, locality, and expands on them so that multiprocessor systems can make effective use. Linux can break the current nodes, or the device memory for non-NUMA platforms into multiple nodes for NUMA simulation. NUMA's features compensate for memory latency effects, useful to scale the virtual machine for large amounts of memory, where memory is placed local to the processors accessing the data to improve performance, balances access to data on various nodes through the processors available. NUMA is a type of architecture which is designed to handle multiprocessing based on the relativity between of a process and a memory, as a process accesses its local memory faster than a non-local memory, which is a memory shared amongst processes. Okay, the drawbacks. NUMA operating system cannot expect the memory access patterns of your application. Processes must be shared when the system is oversubscribed. NUMA system lacks scalability in terms of the memory and CPUs. System heavily relies on the responsibility of the programmer for synchronization. NUMA is implemented in Windows 7 operating system, the Java Hotspot virtual machine, to take advantage of such systems and provide Java applications with automatic memory placement optimizations, which is the NUMA aware allocator. Version 2.5 of Linux kernel, which was further enhanced in subsequent kernel updates, which is basic NUMA support. Okay, that's all from me. Thank you.